problem B of the educational code forces round, and the problem B is the matrix difference. In this problem, we have given in this problem the for a square matrix of integer of size n cross n, and it's defined the property as following. Let's say for each element the side adjacent element is x and y, and the property of that is the absolute difference of both of them. So here the absolute difference is modulo x minus 1, and then we have to find the different number of the number of among of them. So for example, in this matrix we have given 1 4 3 2, and we have to consider the absolute difference of side adjacent. So here difference 1 and 3 is 2, 1 and 4 is 3, 3 and 2 is 1, and 4 and 2 is 2. So here three different number among them. So here the beauty of that matrix is 3. So in this problem we have given the integer n, and we have to find a matrix of n cross n in which each integer from the 1 to n square occur exactly once in the matrix, and such that the beauty of that matrix is maximum. So here we are given the test case, and for each test case we have given an integer n, and in each test case we have to print the matrix of n cross n, where the each element in the matrix occur exactly 1 times, and the beauty of that matrix is maximum. Here if the multiple answer exists, then print any of them. So beauty of that any matrix, for example here the beauty of that matrix is 3. So simply if the size of matrix is here 2 cross 2, and if size of matrix is 3 cross 3, then the beauty of that matrix is n square minus 1. So here you can see here the two test cases are given, the 2 and 3. The beauty of that n is equal to is 3, and beauty of n square matrix 3 cross 3 is 9. Beauty of 8, sorry, n square minus 1, that is 8. 9 minus 1 is 8. So here you can see the compute the absolute difference of side adjacent element, then you get the element 1 to 8. Then that's why here the any square matrix are given. So for any square matrix, the beauty of that matrix is n square minus 1. So how to compute that matrix? So basically idea is that first in this problem we see the for n is equal to 2, if two answer can be possible. One of them, one is 1 3 4 2, and second one 1 4 3 2, and in 3 cross 3 we have get in the matrix this 1 9 2 8 3 7 4 6 7. You can see in the in this if we are getting the maximum beauty if and only if we arrange the number like this: first minimum, then maximum, then second minimum, then second maximum, against minimum maximum. In this way we can arrange that element, then we get the maximum of maximum unique element. So we are arranging in this way, but this is fair. But if n is odd, then this is working fine, but if n is even, then we have some modify here. So here you can see we arrange the first minimum, then maximum, again minimum, and then here one is minimum, and below the maximum, and the maximum, then minimum maximum. So again the minimum maximum is occurring, but when even, then this is in this condition become fail. Here you can say minimum maximum minimum maximum, but here minimum minimum maximum maximum. That's why here we have to rearrange of them. So first here we are arranging minimum maximum minimum maximum minimum maximum, and then we have to reverse of that that row. So if we are reversing of that row, then we get then 13 4 14 3, and then we leave of that third row, and then we again reverse of the mm, uh, fourth row. So you can see here we get, and then we compute the absolute difference of them, then we get the maximum unique element. So first we the idea is that first we arrange the element in minimum maximum, and then if the n is odd, then we leave as it is, but if n is even, then we have to reverse the row, second row, and third near zeroth row, reverse the odd number of row. For here the we are reversing first, then we are reversing third row. Similarly, if n is 5, then we have to reverse first row, third row, and fifth row. Simple that we are reversing the odd number, odd index row. So here you can see we are first we are input the integer n, then we declare the n cross n vector 2D vector, and then we declare two number low and high. Low become start with 1, and high become start with n into n. So here we are assigning the element into the vector. So first we assign the flag to, that means we put the minimum element in the maximum in the matrix. That's why here if flag is true, then we put if I0 J0, then 0 0 we have at b of 0 0 we assigning the low and increase the low value, and then similarly then here after this the flag become false, and then if flag is false, then we are assigning the high value. So simply assign minimum maximum in this way. If n is odd, then we have to do nothing, but if n is even, then we have to reverse of the first row, third row, simple like this. That's why we leave the zeroth row and reverse the first row, and then increase the pointer by 2. So here we are reversing the ith row, and so simple if, and then reversing, then we get the maximum unique element, and then we have to print of that element. So you can see if we are running of that, then you can see for 2 we are getting this matrix, for 3 we are getting this matrix, and for n is equal to 4 we are getting this. And you can check the unique element in this matrix is 1 2 till 15. So if we are submitting this code, you can see if we are submitting, then we get the accepted, and this is the solution of that problem. Thank you.